So if you're in here, I'm going to assume that you're either running both MySQL and MongoDB currently in your environment, or you're thinking about doing so. And this is what you should and shouldn't do when you're thinking about it. Just to introduce myself, I'm Rick Vasquez. I'm a TAM at Percona. I have both flavors of customers, MySQL only, MongoDB only, and customers that have hybrid environments. So I get to see a little bit of everything. So we're going to jump right in with the do's. Use the right tool for the job. I'm going to go in depth later on in these slides. Examine the use case prior to choosing the technology. Scale your database with built-in features, and I stress built-in. And then understand the difference between consistency and eventual consistency. It's very important whenever choosing a database technology. So what does it mean to choose the right tool for the job? Let you read a little bit, then go a little bit into the history of screwdrivers. Another great general purpose tool like general purpose databases. They get you 90% of the way there most of the time. You can often use the same tool on different screw heads. So a Phillips screw head is used for more torque. A flat screw head, if you over torque the screw, you can possibly bust it out, right? So two different use cases that don't break until the extremes of applying too much torque. It's kind of the same way with databases, right? So with a general purpose database, you've got highly relational structural data, and then you've got your document stores and non-structured data. Yeah? So MongoDB, I would not use for highly relational structural data, and MySQL, I would. Thinking about this before you choose a technology is something that you should do, and a lot of people don't do. Kind of obvious. Examining your use case. What kinds of data and how high of a volume of it are you going to be storing? Are you going to be doing high writes and some reads? What are you going to be doing? This is going to determine the type of storage engine that you're going to need, both for MySQL and MongoDB. You're going to need to examine this use case. What degree of consistency do you need? Does it need to be immediately available on every single database node? Is some of your data used more than other pieces of your data? Are there going to be hotspots? Is this data relational in nature? Can't stress this enough. Do not put highly relational data in MongoDB if you don't want to deal with having all this extra space, right? There's a reason that there's relational databases and then document stores. Scaling with built-in features. I'm going to spend a little bit of time on this slide and try and dive in a little deeper than the others. If you've got high write and low read concurrency, this goes back to the storage engine question. Use a purpose-built storage engine for a high write workload. In MySQL's case, right, I'm never going to really just tell you to use MyISAM, but obviously you can get high write throughput if you don't care about your data. Don't throw it away. Mongo's not the same way. You can have high write consistency. Using Mongo rocks, you can have extremely high write throughput. Using MyRocks, you can have extremely high write throughput without sharding, just right out of the box with both of these. Have a high OLTP workload. Think about MySQL partitioning. Right out of the box, you have partition pruning built into MySQL. You have synchronous replication options that are built into MySQL that are native to those. Is your data logically distributed? So if it is, just write off logically distributed, and you have a viable sharding key, why not just out of the box use a general purpose database technology that will horizontally scale with your business out of the box? With MySQL, you're going to run into a few more problems. So use the correct technology whenever you're choosing that. Non-production application loads. So with MongoDB, please use hidden secondaries and secondary preferred queries if you're going to do that. And then with MySQL, understand the difference between asynchronous, semi-synchronous, and synchronous replication. Going a little bit further into consistency, and what exactly is consistency versus eventual consistency. With eventual consistency, everything eventually will be back, right? Asynchronous replication with MySQL, MongoDB by default is going to be eventually consistent. This has nothing to do with strong consistency or weak consistency, but eventually consistent by nature. So immediately after write, it's not going to be guaranteed consistent. With MongoDB, without hacking, there's no way to really change the consistency between your primaries and your secondaries. With MySQL, by nature, with asynchronous replication, it's going to be the same way. But there are options to kind of increase that consistency with semi-sync replication and then synchronous replication with something like Galera cluster or Percona XtraDB cluster. So, do you actually need consistency? Both MySQL and MongoDB can be very strongly consistent, even in async mode, right? And MongoDB just by default. But if you absolutely need to read the data once it's been written, is that a requirement, right? Examine this use case. So I talked a little bit about the options, and then that both databases can have strong consistency. If you do need strong consistency and you're in a Mongo use case, let's say it's a non-relational data structure and it fits perfectly into the document store, do not use secondary preferred reads. Understand your scaling issues if you're going to need consistency. You're going to need to be reading off of that primary node. The don'ts. I'll let you read through these. All right. So deploy the right way is going to be talking about don't put them on the same box. Whatever you do, do not put them on the same operating system. They're going to fight for resources. There's going to be lots of pain. It can work, yes. I mean, you may have seg faults in MySQL. You may have all kinds of crazy cache eviction issues in MongoDB. Things will run sometimes. It turns out to be a pretty bad deal. So don't do that in the same operating system. Docker containers, I'd say it's a mild okay. You can maybe get away from this if you absolutely have to. You're still going to run into problems at the file system level with MongoDB, and then with MySQL with memory issues most likely because your buffer pool is allocated but not necessarily being used. VMs, getting warmer, getting a little bit better. At least you can pin these to maybe some CPUs, but still, you know, you're going to run into issues if both are going to be high throughput boxes or the use case is going to be where the load is going to be high on both boxes. You're going to be taxing the underlying hardware in one way without being able to recognize with the other VM. So separate physical hardware in VMs is fine as long as you don't have two operational database loads on these separate physical hardwares. You know, different spindles, different memory, different CPUs. This may seem really obvious to some of you, but I've run into this quite a bit whenever architecting systems where people are like, yeah, we can just put two technologies on one set of hardware. Do not try non-native replication unless you are an ETL business. Then go by all means and do that. There's going to be tons of data inconsistency between the two unless you have sorted out ETL processes already. There are off-the-shelf products that can help you with this, but they are still going to be painful, and you're going to get nowhere near real-time replication between these two systems. You're essentially trying to put a square peg in a round hole in most cases. One thing that I do want to stress is this doesn't mean don't try and put MongoDB data in your MySQL instance eventually, or your MySQL data in your MongoDB instance eventually. If you do have a use case where you need to run analytics on, let's say, some customer data resides in MongoDB, and your transaction history resides in MySQL, and you need to join those eventually in an in-house use case or an analytics use case, then examine that use case and then choose the appropriate technology, whether that even is MySQL or MongoDB. It could be Hadoop. It could be something like Spark. It could be any other BI tool. But typically, that's going to include ETL in the process anyway. Joins are default. No, they're not. Just because you can join data doesn't mean that you should. In Mongo, you can have data that's semi-relational or even relational, and if you don't mind having duplicate data, that's fine. The join performance in MongoDB is not going to be nearly as high as the join performance in MySQL, just by nature of a relational database, right? The same thing goes for MySQL. Yeah, we have this cool new JSON column, MySQL. What do I need MongoDB for? Well, you need MongoDB because it queries JSON radically different, and the way that it writes JSON is fundamentally different at the storage engine level. So your performance benchmarks aren't really apples to apples. It really just depends on your use case. So take care of your data there. The fourth thing is do not assume that MySQL and MongoDB, even if you have both technologies deployed in your environment, are going to cover all of your bases. You've got to explore proper caching layers with Memcache and Redis, possibly. There's other caching solutions as well. Explore proper log management. Don't just dump your logs into MySQL or MongoDB, even though, sure, yeah, you can have high throughput, awesome log writes into MongoDB. If you're not actually using MongoDB to query or transform or aggregate those logs, there are way better tools to be doing that. Well, Elastic has a great stack to do that. And explore the proper queue and task management. I see this all the time where customers have task managers in, MySQL can do key value store. That's great. You can have tasks and it can read out of it and then remove those. Or in Mongo, the same thing, and having a TTL on a document and then managing that queue. Sure, it can work, but guess what? RabbitMQ and ZeroMQ are going to do it a whole lot better. So, in conclusion, the three things that I really want to stress are think about how you're going to use your data and how you're going to query that data. Don't expect it to fit in any system, and then scale natively. I can't stress these three things enough. Out-of-the-box scaling is much less painful and, purpose-built by the people that built these databases. Am I out of time? Or doing good? Okay. And that's it for me. Do y'all have any questions? Yeah? I guess I covered all the bases. Thanks.